In this problem, you're engineering a new running shoe for Nike. So you have two different materials you're going to choose from for the sole of your shoes. You're doing some tests to find out that a 75 kilogram person, when they're running, their leg comes to a stop after 0.07 seconds if you use material A and 0.18 seconds if you use material B. And we're assuming that the person's leg is moving at a speed of 5 meters per second when it's hitting the ground. And we want to know, well, how much force is that going to mean on the person's leg for material A and for material B? So we know that the change in momentum equals the force multiplied by the time for any object. This is the impulse momentum theorem. The change in momentum is equal to the force acting on that object multiplied by the time during which the object is having the force exerted on it. So the change in momentum, by the way, that is a delta. If you're unfamiliar, delta, just a math symbol for change, is going to be momentum after minus the momentum before, and that's how we get the change. So after the foot collides with the ground minus momentum before the foot collides with the ground is going to equal the force exerted on the person multiplied by the time that the force is acting. Well, since your foot, when you're running, hits the ground and stops, we know the momentum after is going to be zero. There is no momentum after your foot hits the ground, so we can just plug a zero in for that very easily. And the momentum before is equal to the mass of the person multiplied by the speed that the person is moving, or in this case, the foot is moving, when it hits the ground. And that will be equal to the force acting on the person, again, multiplied by the time. Now we're trying to solve for the force, so we're just going to rearrange this equation to get us the force. I'm going to get rid of the zero, so I know I just have negative mass times velocity. And what's the negative for? We're assuming that the person's foot is initially moving in the positive direction, so the force is going to be going the other way, which would be the negative. So that's why we have the negative here. And I'm going to divide by my time. And that would give me how much force is acting on this person's foot. Now I hope you realize that it doesn't matter if we're talking about the first material, material A, or the second material, material B. The equation is exactly the same. The momentum before the person's foot hits the ground is going to be exactly the same. It's mass times speed. The only thing that's going to change is the time. So my overall equation is going to work for finding the force for both material A and B. So I'm not going to redo the math and all the algebra that I just did to get both A and B. I'm just going to plug in the time for material A and get the force for A, and the time for material B and get the force for B. Because the mass and the velocity don't change. So here's what we're going to get. First, I have to put my mass in, so we'll do material A first, just because it's alphabetical. So the mass is negative 75 kilograms. And the speed was given at 5 meters per second. And we're going to divide that by time A, which is 0.07 seconds. And that will give us the force for our A material. And when I divide those numbers, what I'm going to get is 5,357.1 newtons for material A. I'm just going to use the exact same equation now for material B. The masses doesn't change. The speed doesn't change. The only thing that changed was how long it takes your foot to stop. Now it's 0.18 seconds. And that will give us the force for the second material, or the B material, and that would be 2,083.3 newtons. And that's the difference.